All right, example 5 is a bearing problem that's a little bit more involved than the last one. We have a boat that leaves the entrance of a harbor and travels 18 miles on a bearing of north 40 degrees east. The captain then turns the boat and travels on a bearing of south 50 degrees east for 20 miles. At that time, how far is the boat to the nearest tenth of a mile from the harbor entrance? And what is the bearing to the nearest tenth of a degree of the boat from the harbor entrance? So we'll start off by just labeling where the harbor is. We'll just put a dot. And we'll draw a very light north-south line, okay, vertical line. We know that the boat travels on a bearing of north 40 degrees east, so I know that I want to draw my line segment to the right of the north line, and the angle that it makes with the north line has to be 40 degrees. So north 40 degrees east for 18 miles will look something like this. This angle will be 40 degrees. The distance will be 18 miles. And when the boat makes a turn, so the boat's here, it now makes a turn on a bearing of south 50 degrees east. So we'll draw another north-south line to get our bearing from this point. This time we're going from the south, so our angle that our line segment will make will be with the south, from the south. So I want a 50-degree angle, and I'm going for 20 miles southeast. So this angle in here will be 50 degrees, and the distance is 20 miles. Now I know at this point that this angle in here is 90 degrees, but we'll get back to that in a minute. Because part A just asks how far is the boat to the nearest tenth of a mile from harbor's entrance. So I'm looking for this distance right here. And so we'll call that D. Now this angle, it's a 90-degree angle, which means I can use the Pythagorean theorem, but let's confirm this 90-degree angle. I know that the little angle in here is 50. I actually know that this angle to the left is 40 degrees because of something called alternate interior angles. This angle down here is 40 degrees, so is this one. Anytime you have two parallel lines and a line crosses them, the alternate interior angles are equal. So this angle and this angle would be equal. So this is 40 degrees. And because that angle is 40 degrees, I know I have a 90-degree angle in here. So I know that D squared equals 18 squared plus 20 squared, or D equals the square root of whatever 18 squared plus 20 squared is. This is approximately 26.9 miles. So I know this distance right here is 26.9 miles. Now the next question says to find the bearing of the boat from the harbor. So we want to know the bearing from here to here. This is where our boat is right now. This is the harbor. So we need to find this angle, and then we can figure out whether we're going to be going from the north or the south. Remember, if this angle is greater than 90, then we'd have to come from the south. If it's less than 90 or equal to 90, then we'd be coming from the north. So if I want to label this, if it's helpful to label this triangle ABC, B for the boat, C for the right angle, I want to find angle A. So to find angle A, I'm going to use a relationship between these two sides in A. I have the opposite and I have the adjacent when it comes to angle A. So I know that the tangent of A is going to equal 20 over 18. So A would equal the inverse tangent, or the angle whose tangent is 20 over 18. Our calculator is in degree mode, so we'll do second tan 20 divided by 18. We get A is approximate, and if we're rounding to the nearest tenth, even still here, we're getting A is approximately equal to 48 degrees. And so if we know if we add up these two angles, we can find the angle that this line segment from the harbor to the boat, that angle is 88 degrees. So that is less than 90. And again, it's really difficult to tell when you hand draw these, because I can see that the angle that I have drawn here looks slightly greater than 90, but I didn't use protractors when I was drawing these angles. This is just a rough sketch. So the math tells me that this angle is 88 degrees. So I am going to come from the north, so my bearing is going to be north 88 degrees east. So part A was how far is the boat from the harbor. That's 26.9 miles. And part B, the bearing is north 88 degrees east. Okay, the next problem, I'd like you to pause the video and try one of these problems on your own. This one is a little bit more challenging because instead of telling you how far the boat has traveled, it gives you how long it's traveled and the speed. And so you need to use distance equals rate times time to find the lengths of those sides. But otherwise the problem is very similar. All right, we have a plane that flies from an airport on a bearing of north 45 degrees east for 2 hours, then turns on a bearing of south 45 degrees east for 3.5 hours. If the speed of the plane is 390 miles per hour, what is the plane's bearing and distance from the airport after 5.5 hours in flight? Round distance to the nearest mile and angle to the nearest tenth. So again, we're going to start by just labeling where the airport is. So we'll start with the airport, put a point, and we'll just draw a very light north-south line. And this problem we are going north 45 degrees east for 2 hours. So to figure out my distance, I know the angle has to be 45 degrees in here. Right, I'm coming northeast, so I'm starting at the north line, making a 45-degree angle. I want to know how long this line segment should be. I know that distance equals rate times time. So distance is going to equal, for the first part, for 2 hours, the rate is 390, the time is 2, so it's going to be 780 miles. So I will draw my line segment, and this will represent 780 miles. Now the boat is here, and the pilot turns on a bearing of south 45 degrees east. We'll draw another north-south line. And so we're going to go south 45 degrees, so this angle in here should be 45 degrees. And we're going to the east, so again to the right of this vertical line. This angle is 45 degrees. The distance is 390. Only this time it's going to be for 3.5 hours, so 390 times 3.5. And we get 1,365 miles for this distance. Make that a little longer. Again, not drawn to scale, but I know that the distance is a lot longer. And I want to find the distance. So here's the plane after the second turn, after the 5.5 hours. I want to find the distance from the airport to the plane. Again, we'll call that D. And again, I have a 90-degree angle because, again, alternate interior angles. This angle right here is the same as this angle right here. 45 degrees. Since both of these are 45 degrees, this angle in here is a right angle. Okay. So I know that distance is equal to the square root of 780 squared plus 1365 squared. Okay, evaluating on my calculator, the square root of 780 squared plus 1365 squared gives me approximately 1,572 miles. All right, so we've got the distance from the airport to the plane after the 5.5 hours, 1,572 miles. Again, I have to find this little angle in here. We can call it alpha. And I've got a right triangle again, so I know that the tangent of alpha is equal to the opposite, which is 1365, over the adjacent, which is 780, or alpha is going to equal the inverse tan of 1365 over 780. We'll evaluate that on the calculator. Second, tan 1365 divided by 780. Hit enter, and we want to round to the nearest whole degree. So we get 60 degrees. This little angle in here is 60 degrees. Now the 45, this angle now from here to here is 105. If we take the 45 plus the 60. So this is too big. Too big to go from the north. So we want to find, let's call this little angle in here beta. We want to find beta. So beta is going to equal 180 minus the 105. So we get 75 degrees. So if this little angle in here is 75 degrees, we now have a south bearing. So we're going to have, our bearing is going to be, will be south 75 degrees east. Now both of these problems we used east, but either, the problem is done the same exact way if you're heading towards the west. But your first job is to find the distance, and then the second job is to find the bearing. And in this unit, all the angles that we're dealing with are, the application problems are right triangles. So you can use the definition of the trig functions of acute angles, where in the next unit we're not going to have right triangles, we're going to have what we call oblique triangles, and so we'll need a different method.